Hello, and welcome to a little video about linear combination, but we're going to take it a little step further. All right. So, in the previous linear combinations that we were doing, what we always had was an opposite number. Either we had a positive 4 and a negative 4, positive 2, negative 2, etc. Most systems don't have those opposites right away, so we're going to have to create them. Let's start with this one. Now in this system, I noticed something unique. This is not always going to happen, but we have plenty of examples left of more common types. In this example, we have actually the same exact number for y. We both have -9s for y. I would like to make them opposite. In order to make them opposite, we're going to multiply both sides of the equation by -1. -1 creates an opposite. Let's do it. I'm going to zoom out a little bit. All right. -1 times -2x is positive 2x. -1 times -9y is positive 9y. And -25 times -1 is positive 25. We're not doing anything to that second equation because we only needed to fix one of them to make a match. So I'm just going to rewrite the second equation as is underneath the new first one. Notice that now our y's are opposite. Okay? We're going to add them going up and down. Let's do it. Our y's cancel. Positive 2x plus -4x is -2x. I got ahead of myself. 25 plus -23 is 2. Let's divide both sides by -2. X equals -1. It doesn't matter which equation we plug back into to find y. I feel like using the top equation. I like rewriting it, but you can start plugging in immediately if you so choose. Right. So instead of x, I have a -1, and the rest of my equation stays exactly the same. -2 times -1 is positive 2. Everything else stays the same. We have 2 more steps to take, and that's to subtract 2 from both sides. And then to divide by -9. Y equals 3. Don't forget, we've got to write our answer this way. All right. This is the best case scenario. Most of our systems of equations are going to look like the next one, where we have to mess around with both the top and the bottom equations. Okay. All right. So, in number 2, what you should see is that the x's and y's are kind of prepped. One of them is negative, one's positive. So we have a -4x, positive x, positive 9y, -3y. So they have the potential to be opposites. We just need to make the numbers between the symbols and the letters match. Let's make the x's match this time. So in front of the x on the second equation, I actually have a 1. I want to make sure to write it in, because this is going to be kind of essential to this whole process. All right. I am going to multiply the top equation by the number next to the letter we're trying to eliminate of the bottom equation. So I'm going to multiply both sides here by 1. And I know you think it might seem silly to multiply by 1, and it kind of is, but we're just practicing. The bottom equation, we're going to multiply by the other number in front of x, and we're going to multiply by 4. Now you're probably wondering, why aren't you multiplying by a -4? Well, I don't need to change the symbols. I already have a positive, I already have a negative. So I don't want to mess around with the symbols that I have. I want to keep The top one negative, keep the bottom one positive because they will cancel as long as they're both 4s. All right, let's distribute and write our new equations. First, I'm going to distribute the 1 and then the 4. Okay. 1 times negative 4x is negative 4x. 1 times 9y is 9y. And 1 times 9 is 9. 4 times 1x is 4x. They're opposite. Awesome. 4 times negative 3y is negative 12y. 4 times negative 6 is negative 24. And we are ready to add. Let's do it. The x's cancel. Good. That was the point. 9y plus negative 12y is negative 3y. 9 plus negative 24 is negative 15. And we get to finish that by dividing both sides by negative 3. Y equals positive 5. It does not matter where we plug that in. I feel like doing the second equation. So I'm going to go ahead and rewrite it. And then we're going to plug in y. We have x minus 3 times 5 equals negative 6. Okay. First I'm going to multiply. 3 times 5, or negative 3 times 5 is negative 15. Everything else stays the same. I'm going to add 15 to both sides of the equation. X equals 9. Beautiful. 9, 5 is our answer. Let's use the same line of thinking for number 3. Ooh, number 3 is a little weird though. Look at that. All the x's and all the y's are all positive. So we're going to have to force a negative to happen. We got rid of the x's last time, so let's get rid of the y's here. Okay. So I'm still going to do what I did in the last problem, where I'm going to multiply the top by the number from the bottom and the bottom by the number from the top. There's going to be a little twist to it. You just wait. Okay, here's the twist. I want one of them to be negative, right? I don't want them both to be positive. So in order for that to happen, I'm going to make my my 6 negative. Now we could have made the 4 negative. It doesn't matter. Just for consistency's sake, make the top ones negative. All right, let's distribute. Negative 6 times 5x is negative 30x. Negative 6 times 4y is negative 24y. And negative 6 times negative 14 is 84. On the bottom, 4 times 3x is 12x. 4 times positive 6y is positive 24y. Yay, opposites. And lastly, 4 times 6 is 24. All right, let's add. The y's cancel. That's far too long. There we go. Negative 30x plus 12x is 18x. 84 plus 24 is 108. It's negative 18x, my bad. And then I'm going to divide both sides by a negative 18. X equals negative 6. Yes, negative 6. Let's plug it into the top equation. Always use the original ones. Not just, to be careful, but also you don't want to deal with these large numbers that we get, It's so much easier to make a mistake when the numbers are bigger. All right, so it's 5 times negative 6 plus 4y equals negative 14. Five times negative 6 is negative 30, plus 4y equals negative 14. I'm going to add 30 to both sides. The 30s cancel here. So you have 4y equals 16. And we finish by dividing both sides by 4. Y equals 4. Negative 6, 4. Okay. Let's continue. All right, here we are on number 4. Now number 4, just like the previous ones, we can choose either the x's or the y's. I like to go for the ones that are already set up to be opposite, so let's cancel out the y's. So I'm going to multiply the top equation by the bottom number. And the bottom equation by the top number. Now I'm not changing any signs, so I'm not using a negative 7 or a negative 2 because they're already prepared. One is negative, one is positive. All right, let's distribute. I'm just going to draw my arrows now to save a couple seconds. All right. 7 times negative 4x is negative 28x. 7 times negative 2y is negative 14y. 7 times 14 is 98. 2 times negative 10x is negative 20x. 2 times 7y is 14y. 2 times negative 25 is negative 50. Let's add. Negative 28 plus negative 20 is negative 48. 98 plus negative 50 is 48. We're going to divide both sides by negative 48 since that's the number in front of x. X equals negative 1. Now let's plug it into, what do I feel like? The first equation. Yeah, I feel like the first equation. There's no real reason, I just like how it looks today. Maybe if I made this video yesterday, I would have chosen the second equation. Alright, so I'm plugging in that negative 1. 4 times negative 4 times negative 1 is positive 4. Everything else stays the same. Let's minus 4 from both sides. Be very careful, don't forget the negative in front of the 2y. Because we're going to have to divide both sides by negative 2. Here's our answer. Negative 1, negative 5. Okay. So essentially, this is the method for every single problem elimination. You can do them all this way. Unless, of course, they're already opposite, then you can start adding them immediately. Number 5. I already wrote the things, so I could just talk about them because my handwriting is so much better if I write it ahead of time. Explain when each method is a good method for systems. First, graphing. Graphing is best when both equations are y equals. Because we have it set up with the slope there, with the y-intercept, we can graph them by hand in a calculator and find the point of intersection, which is our answer. And of course, it is way easier to graph something if it's already in that y equals form. Substitution. That one is good when one equation is an x equals or y equals. And it tells us exactly what we should be substituting. Yes, you are right. we did substitute when both equations were y equals. And that's because any method works for any problem. You might have to do some rewriting, which is probably the most frustrating part, but they might end up looking kind of ugly when you want to graph them from rewriting them from substitution. So we might end up with some decimals or fractions, which is unfortunate. So doing substitution would be much, much easier to work with whole numbers. Lastly, linear combination, what we just did, is great when both equations have their x's and their y's on the same side. So we have an x and y on one side and a regular number on the other. This is best because they are set up, we can force opposites like we just did, and very simply find what x and y are. Now, of course, you can rewrite systems that have x and y on one side as a y equals or an x equals to do substitution. Your numbers might look kind of ugly. You can also rewrite them to graph, but your equations might end up looking kind of ugly. So, you can really use any method for any type of system. However, this is when they're easier. Graphing when both equations are y equals, substitution when one of them is like that, and linear combination when x and y are both on the same side. I hope this was helpful. If you have any questions, please feel free to ask me or whoever's helping you out with math. Have a wonderful rest of whatever day it is for you. Bye!